The Voyager 1 space probe, which has been traveling through space for more than 40 years, has made an important assertion during a trajectory beyond its initial mission. It has exceeded all expectations as it was originally expected to last only 5 years. Now, Voyager 1 has detected the presence of 300 unknown objects passing through space. This discovery has completely changed our understanding, as these objects were found to be plasmas from large star explosions that occurred millions of years ago. Join us on this journey through the cosmos to discover what these items, located by Voyager 1, are all about. Unlike previous years, when we were only able to investigate data within our solar system, thanks to the innovation provided by Voyager, we now have access to information beyond it. In August 2012, Voyager 1 officially confirmed the boundaries of the solar system by crossing the heliopause. However, this milestone was not easy to achieve. As the probe moved farther and farther away from the sun, the amount of sunlight available to power its instruments and systems significantly decreased. The spacecraft's power is generated primarily from 3 radioisotope thermoelectric generators, which convert the heat produced by the natural breakdown of plutonium-238 into energy. As the heat output of these thermoelectric generators has decreased over time, the available power has diminished, affecting the operation of numerous onboard systems, including scientific instruments, data transmission, and communications. To conserve power, non-essential systems and devices have been shut down, disabled, or placed in a dormant state. As power continues to decline, it will be essential to optimize or shut down Voyager 1's critical systems to prolong its operational life. In its current state, it will not function for much longer. Even in its reduced capacity, however, it remains immensely valuable to us. But the enormous distance between Voyager 1 and Earth presents a significant challenge to maintaining effective communication. As the spacecraft ventures into interstellar space, Voyager 1's signal strength has weakened. It takes more than 21 hours for signals to travel from Voyager to Earth. The weak signal, combined with interference from background noise, makes it difficult to transmit and receive information. Furthermore, the temperature transition from the heliosphere to interstellar space exposes Voyager 1 to drastically different thermal conditions. In the heliosphere, the spacecraft was closer to the sun and experienced higher temperatures, whereas in interstellar space, it faces extremely low temperatures. The Voyager 1 probe is equipped with dust detectors specifically designed to measure the density of interstellar dust in deep space. But communication with Voyager 1 has become increasingly difficult due to limited resources. NASA's worldwide antenna network is expected to receive the mission signals, but this has resulted in fewer communication opportunities than before. Nevertheless, a fascinating discovery recently emerged. Amid the data stream, Voyager 1 detected an intriguing anomaly: the presence of 300 unknown objects passing through interstellar space. This discovery has puzzled scientists around the world because it challenges our understanding of the cosmos. Are these objects remnants of ancient celestial bodies drifting through space? Are they relics of distant star systems or evidence of previously unknown phenomena? Although the data transmitted by Voyager can typically be easily deciphered, in this case, the data was encrypted, raising many questions but offering few answers. Strangest of all, despite the mysterious nature of the data, Voyager 1 appeared to be functioning smoothly. Its communication link with Earth remained intact and the signals stayed strong, allowing valuable information to reach NASA without much trouble. Apparently, none of the spacecraft safety systems were triggered, indicating there was no immediate threat. This rules out a possible attack. So, what could be causing the telemetry data to appear scrambled or faulty? Could it be the result of interference from cosmic phenomena, such as radiation or high-energy particles? Or is it possible that we are dealing with a completely unknown phenomenon that defies our understanding of space? The only way to uncover the truth was to conduct a meticulous analysis of a wide range of possibilities. The NASA research team thoroughly analyzed the systems, considering the effect of cosmic radiation on the electronics and the possibility of temperature fluctuations affecting their sensitive instruments. There was a possibility that something occurred just before Voyager entered the heliosphere, and that natural changes in its path created issues in data transmission. However, Voyager 1 was not precisely in the region where those natural changes were concentrated enough to cause these problems. So that didn't seem to be the answer. The team also investigated the complexities of Voyager 1's communication systems, exploring possible distortions caused by cosmic noise interference or even slight changes in its trajectory. The search for answers led to a meticulous evaluation of all these potential factors. The spacecraft's systems were examined in detail, considering the impact of cosmic radiation on electronic components and the possibility of temperature fluctuations affecting its sensitive instruments. Yet, while it might sound like a simple task of checking boxes on a list, in reality, there was a tremendous amount of work to be done. Consequently, this research was not immediate. It dragged on for weeks. The team advanced data processing techniques, developed innovative algorithms, and ran simulations of various scenarios to discover the root cause of the unusual anomalies. At the time, this was the only way to determine what was causing the problems, and all that effort was not in vain. After months of receiving encrypted data from the spacecraft, scientists and engineers were, sooner or later, able to restore clarity and reliability to the data coming from the far reaches of interstellar space. The cause of the problem was traced back to Voyager 1's attitude articulation and control system, or AAC specifically, an onboard computer that was supposed to be inactive. Remarkably, was discovered that the AACs had begun using this computer, despite it not being operational for years, leading to corruption of the transmitted data. However, the rest of the spacecraft remained operational and continued to collect data to identify the source of the problem. Engineers acted quickly and sent a command to Voyager 1, instructing the AACS system to switch to the correct computer to transmit telemetry data. Although the solution was low risk, it required a great deal of patience due to the significant delay caused by the distance between Earth and Voyager. One radio signals take nearly 22 hours to travel each way. As a result, the troubleshooting process required careful coordination. There was, however, one major concern. Voyager 1 had been built decades ago and had performed excellently up to that point. Therefore, finding a solution to modern issues presented a significant challenge. It became necessary for the engineers to consult several manuals from the 1970s, and that is exactly what they did. After careful examination, they found a simple fix to the problem by restoring the device responsible for data transmission. In this way, they managed to resolve the issue without affecting any other part of the spacecraft. The experience and dedication of the engineering team played a vital role in restoring clarity to Voyager 1's communications. Their efforts underscored the importance of leveraging past knowledge and combining it with modern technology to address the challenges of space exploration. Engineers suspect that the deviation using the non-operational computer was triggered by a faulty command received from another onboard system. This speculation points to an underlying issue within the spacecraft's complex computer network. Task managers remain cautiously optimistic and emphasize that this incident does not pose a threat to the long-term well-being of Voyager 1. The spacecraft corrected the error and resumed its mission once the correct systems came back online. Thank you very much for watching the video. Don't forget to like and subscribe, and I'll see you in the next one. As Voyager 1 continues its journey through the vast, uncharted territories of interstellar space, the implications of its recent findings are profound. The detection of 300 unknown objects, likely plasmas from ancient stellar explosions, has sparked a wave of scientific inquiry, raising questions about what else may be drifting in the silent darkness beyond our solar system. These plasmas Remnants of supernova offer a unique glimpse into the cosmic past. Scientists believe that by studying their composition and behavior, we can learn more about how elements are distributed throughout the galaxy, how stars die, and how the raw materials for new star systems are formed. It is a reminder that Voyager 1 is not just a relic of the past, it is a tool that continues to reshape our understanding of the universe today. Despite its age, Voyager 1 remains one of the most sophisticated pieces of engineering humanity has ever launched. Its instruments, though outdated by today's standards, continue to function thanks to careful power management and the unwavering dedication of mission control. Every new transmission it sends is a small miracle whisper from the edge of the known, traveling billions of kilometers to reach us. What makes this mission even more extraordinary is the lasting legacy it carries. On board Voyager 1 is the famous Golden Recorder time capsule containing sounds and images from Earth, meant to tell the story of our world to any extraterrestrial life that might one day find it. It includes greetings in 55 languages, music ranging from Beethoven to Chuck Berry, and sounds of nature from a baby crying to the roar of the ocean. This symbolic gesture, dreamed up by a team led by Carl Sagan, reminds us that Voyager 1 is more than just a machine, it's a messenger. It is a testament to human curiosity, creativity, and our desire to connect with the cosmos, even, if only, to say we were here. Looking ahead, mission scientists are preparing for the eventual end of Voyager 1's journey. Its power source is slowly fading and is expected to last only a few more years. By 2030, most of its instruments may be shut down, and the final signal may soon cease afterward. Yet even when it goes silent, Voyager 1 will continue to drift silently and steadily into the unknown. It will become a ghost ship of humanity, carrying our message across the stars, possibly for millions of years, long after Earth itself has changed beyond recognition. Long after the lights of our civilization may dim. In the grand scope of space and time, Voyager 1 is but a grain of sand on a vast shore, and yet it carries with it the hopes, dreams, and questions of an entire species. So what lies ahead? Could future space missions travel even farther, with more advanced technology, to follow in Voyager's path? Might we eventually send crewed missions beyond the solar system? Or perhaps someday someone or something will find our little golden disk drifting through the dark. For now, Voyager 1 continues pushing the boundary of what's possible. And as we wait, we listen, we wonder, we dream.